Good evening and welcome to the BS and Beer Show. BS stands for Building Science. If you're new here, hopefully we've got some new people joining us. Tonight we're going to talk about wood fiber insulation, specifically made in the US, which we're pretty excited about. I'm Emily Mottram and it is dry January, so we're having water tonight. You're going to get over the holidays. BS and Beer is a grassroots movement, right? Everybody comes here and volunteers their time to do the show through our local meetup groups and our once a month show here online. So we encourage you to start your own local group if you haven't. Keep reaching out to us. I would say Travis probably has the most current list of other people who have started chapters in other places. So if you're not sure if there's a chapter in your area, reach out to us and let us know. Post it in the chat box. You probably already see the chat box going off on the bottom of the screen. Make sure that you introduce yourself, tell us what you're drinking in the chat box, and pick everyone or all host and panelists so everybody can see what you're posting, not just the people on the screen. Today's video recording will be available at Green Building Advisor after the show and also on our YouTube channel. So all past shows are up there. And we want to say a thank you to our media partners, Green Building Advisor and Fine Home Building Magazine, for helping us make this happen once a month. So Ben, if you want to do announcements.
Sure. Okay, so I'm Ben Bogey, production manager in Connecticut. And this evening I'm drinking a lovely single barrel bourbon old fashioned. So we've got a couple of announcements coming up in the end of February. Is going to be the International Builders Show put on by NAHB in Las Vegas. That's February 27th through 29th. We will be doing a special building science symposium, BS and Beer Building Science Symposium, the day before NAHB as part of the International Builders Show. So if you're coming out for the show, come in the day before and join us for that. Travis and I will also be anchoring the High Performance Zone, Construction Performance Zone, and we have a phenomenal lineup this year of great content, presenters, products to show off the cutting edge of what we're trying to do in the BS and Beer group here. So come to IBS. It's fun. It's Vegas. What's not to like? The BS and Beer Show will be participating in an exciting event on March 7th, put on by our friends at the Passive House Accelerator. This will be a groundbreaking 24-hour global online conference called Reimagine Buildings 24. They will circumnavigate the globe, unveiling a new innovative building project every hour, complete with actionable solution sets, expert insights, and key lessons learned. Get your tickets at the link going to be posted in the chat box in a moment. And then our upcoming show next month is going to be multiple chemical sensitivities and environmental sensitivities with Corinne Segura. So that's going to be a topic. So with that, I kick it back to you, Emily, since Travis is stuck behind a steering wheel.
Yeah, and he's clearly not drinking anything. So wait, maybe he has
coffee. Just a coffee.
All right, so I have the pleasure of introducing our guests tonight. First is Dan Edelman. Maybe some of you guys know Dan. He's been working in the built environment for 20 plus years. For the past 12 years as an advocate for vapor open and airtight building enclosures. Dan has been a guest on the BS and Beer Show multiple times, so you're familiar with him. He often tunes in the chat box as well. He's the business development manager for TimberHP, and he's an avid home brewer in addition to his interest in building. So Dan, what are you drinking tonight?
So I am in the great state of Vermont right now with Shelterwood Construction. We're going to be doing some timber fill tomorrow. I'm having Kramer and Kin. It's a brewery, agriculture, and community based in Alburg, Vermont. So it's nice B because I feel sometimes that I'm a building envelope expert, like a B.
That's awesome. So we also have Jason Todd with us tonight. He's worked as a contractor, energy auditor, insulation installer, project manager, and has held various roles supporting energy efficiency programs, educating contractors, and HVAC professionals on building science best practices. He is the director of building science and industry support for TimberHP. Jason, what are you drinking?
I'm drinking Fogtown.
Oh.
Little Night Nurse, which Gregory Isaac fans out there, I don't know, but I also am drinking it in a glass I made from a friend of mine who's a glass blower out here. Well, I think he's moved since, but David Jacobson. I was actually I am a former professional brewer. I don't always talk about that much, but always interesting when you can blend science and passion. And I think that's the stuff that Dan and myself and Jess that you'll meet in a moment, which I would say is the only wood fiber insulation home brewer I know of.
I was gonna say, I think Jess is gonna win. She's cooking things up. So we have, last but definitely not least, Jessica Vignell brings a decade of experience in paper industry to her role with TimberHP. She is the operations manager. She oversees the entire manufacturing process from the arrival of chips in the wood yard to the final packaging and shipping of TimberHP's products. And I will tell you, we recently got to tour TimberHP and she answered all of our crazy questions while also trying to cook up a batch of wood fiber bat insulation. So it's awesome to have you here. Jess, what are you drinking tonight?
Thank you for having me. I am at work, so I'm drinking a nice lemon lime Canada Dry. It's a new brand for me. I'm switching from Polar to test this out, so it's a pretty big deal. I thank you for sharing a little bit about my background. I feel a bit of an outsider with this group. I've been in manufacturing my whole life, so I'm really excited as someone who is super interested in how something is created. I'm super excited to hear how people are using it, what their thoughts are on the product, and thank you for having me.
Absolutely. So I hear that you have a presentation to share, so let me give someone permission to share. Oops. All right, hosts and panels, you should go ahead. Jason, you should be all set.
All right, I have to remember how to do that on Zoom. I've gotten so
There's a green share button on the bottom, and then you'll have to find the right screen.
gotcha. So I will start here. And there we go. Does that look all right?
Yes.
Yeah.
Yep.
Great. Dan, do you want to kick it off? Your video is all right. The audio is okay. The video is a little choppy, but maybe start a little bit with the first couple slides.
Okay. Yeah. So basically, welcome to TimberHP. Again, our wood fiber insulation. I find that there's always, and I love the slide. I would say also that the three questions that I get most asked is air, water, and bugs. So all three of those, we do have some products mixed in with the wood. You know, we are building 99% of our homes with our wood anyway. So it really is kind of a shoe-in product that really makes sense in the industry in the US and North America, I should say. So we have Canadian viewers, you know, out there. But really it's carbon storing. It's going to be a negative embodied carbon, which is all, you know, concrete being one of the highest ones. We can actually offset some of that. It is a high performance insulation. It's going to be relatively stable. It's highly recyclable. So that's basically, it's wood. You know, it's very easy to renew and reuse and everything else. It's non-toxic. There's no irritants or anything in the material itself. I'm going to say that we're a Class A flame spread. That's the ASTM E84 test. On the products that we're currently have out in the market now, that's going to be the timber fill, which you can kind of see in the diagram. You could do den decking with that product. You could do a blow-in attic. I know we just did a couple attics in the Kansas City market with Travis and Jay Bruton. I know Ben has also used that product, and Emily. So all three of the hosts, the brew have the timber fill product. The timber bat product has actually been developed, and now we're just leading on. And thank you very much to Jess for basically perfecting the timber bat product, and that's getting rolled out right now So that should be introduced into the market very soon.
Awesome. I will go through a couple of these real quick. Dan touched on a lot of the points, and Jess is completely out of the loop on the presentation, although she may have seen a few things. I think by the time we get to the 5th or 6th slide, I'm going to turn it over to you and just tell me when we need to move forward. But as Dan had mentioned, softwood species, it really is quite a wood basket we have here in Maine. Jess can speak to some of the manufacturers and the support we get from industry. But the important detail here is that it is predominantly just wood that makes it that comes from residuals, not from harvesting of trees, unless it is something that we would be supporting a chipping industry or operation because it's an FSC certified forest stand that needs thinning. But really, that is the most important thing, I think, out of the raw material source that we have, is that it's a byproduct of other industries. Touch on these real quick. You can find all of this information online. And I think Dan also touched on a few of these things. Timber fill is in the market currently. It's essentially a cellulose product. It's blown in for attics or into walls. Very nice properties, great to work with. I've spent a lot of time in past lives with cellulose insulation, and I really appreciate blowing timber fill. Timber bat as well. We're just kind of dialing some of that in. Was working with Jess today on some of the characteristics there. Fascinating operation, and seeing it all come together, very impressive. But in the end, very flexible, R4 per inch, Class A, as Dan had mentioned, and we will have configurations for steel framing and wood framing, as well as some acoustic bats. Great stuff to work with as well. And then coming around the corner this spring into summer, by the time I would say midsummer, we should be looking at a board product, a rigid board product. The square edge will be available this year. Thicknesses from 1 inch up to 9 1/4, various densities, a little bit different formulation. We don't have a lot of that in this slide, but maybe if we have some time, Jess could talk to some of those things that stand out differently. And that TNG profile is something that we will work on in the future. That will not be in 24, but hopefully in the coming year. And I would say that at this point, I'll start the transition, and Jess, feel free to hop in. We've got a couple of slides just about the facility itself and then just the workflow. I don't know if you want to add anything about what this location was previous to what you're seeing now in the picture here.
Yeah, so sure. So you're gonna still drive, right, Jason?
I will drive. Just tell me to move forward when you're ready.
So what's really amazing about this photograph, you're looking back in time as you look from this side of the building toward the river behind it. So this building you see in the front was built in 1980. This is what houses our manufacturing facility today. You go behind that and there's a whole nother mill, and our office area was a whole nother manufacturing facility going back to 1887. So this exact site has so much history in manufacturing and for the state of Maine. But for mills, paper mills in the state of Maine, 1980 is a pretty new building, actually, if you look around, which is why Josh and Matt selected this site. It's been such an amazing transformation. What you can see out front, the huge cranes that Chimbro, our contractor, had in place to lift the cyclones and the structural steel up onto the roof. The roof line you're looking at there is like, 70 to 90 feet on the two elevations. So it's quite an impressive plant. We are on a really small site. I joke with our wood vendors that we claim the title for the smallest wood yard in Maine. So if any of you have ever, our whole site's 11 acres, and where I receive my wood is about less than the size of a Walmart parking lot. So we're operating in pretty tight constraints, getting our wood flow into the yard, loading it in. I think you can, Jason's got the aerial view there. So we're really trapped between the main street and the river, and that's where our mill sits. So
Yeah. And on the right-hand side of the screen is the chip shelter in that green square up top, part of the yard, which on the left is the yellow square or rectangle. And some of the workflow that we'll go through in the coming slides, we've got receiving of chips, but then a process throughout the whole building. And I think one of the neat things about this site that was always related to me is that the not only was the infrastructure in place because it had been decommissioned not very long ago, but that the equipment for wood fiber manufacturing of board and bat is quite a long process. And you can see that in red and also in yellow.
yeah.
And that is a significant portion of the production hall where there used to be paper equipment running through.
Yep.
So I have here part of the quality workflow manual. I was stealing a little bit out of operations here. And, you know, maybe Jess, you could talk a little bit about the flow, but then we can go in and each one of these boxes, we've got some representation in some photos in the coming slides.
Yeah, I think this is a really interesting manufacturing process. I hope other people find it interesting. There's some new pieces of equipment that I learned about coming to work for TimberHP, but if we follow the process flow diagram, wood receiving and chip screening, I think one of the most interesting parts starting right at this first square is that we're taking residuals from another process. Lumber mills are making dimensional lumber, trees are round, lumber's not, there's excess. That excess is chipped and sent to us. It would otherwise possibly go to a biomass facility. We're repurposing it and adding value to that. So we're actually using those residual chips for our raw material. Bring in those chips. Chips aren't perfect. When you receive them, you need to screen them. You need to take out the big ones, take out the sawdust and the little ones. So that's what we're doing in the wood yard. Now you need to convey them and start warming them up. So that third box there, the pre-steaming bin, it's been pretty cold lately, actually. And we've had some trouble with frozen chips. So you need to put those chips, if you can just picture, you know, a tank, we're adding steam, gentle steam into the bottom of the tank to warm those chips up, get them a little more pliable, flexible, definitely thaw them out if they're frozen. So then next they're going to go into the digester. And the best way that we explain a digester to people, it's really just like a tall, kind of tall, thin tank, but it's a pressure vessel. So when you have steam under pressure, the temperature rises. So we're cooking chips at about 97 PSI, 330 degrees. And that's where we're really breaking down, loosening the chips, the lignin that holds the fibers together. So we have a recipe that we cook to get certain fiber characteristics, but the real heart of this whole project is in a piece of equipment called the refiner. And you, Jason, do you have a picture of the refiner plate later on?
Yeah, actually, I do. I put one of those in there. You want to move through the slides? I think most of these stages are laid out in. Oh,
Okay.
You've got a real one. There we go.
We have one on the desk. This is one that was smashed. So this is one piece out of 12. If you had 12 of these, it would make a perfect circle. Then if you had two perfect circles, you're going to push them together and grind the wood in between them. So it's a pretty rugged piece of equipment spinning at 1800 RPM. But really this is a different design plate than I'm running right now. But the way that the engineers design the plates, how the chips move through it, how long they stay in certain segments, that's really the magic about how we get the fiber quality that we want. We'll just put that down. Okay.
More on this, or you want to move on to the individual slides?
So just quickly, I'll just let people have the process in their mind. Once the chips have been separated into fibers, they're about 50% moisture, so you need to dry them. And really, it's just a big tube with natural gas, heated, hot air. We blow the fiber into the flash tube dryer. It comes out the other end at about 13% moisture. And then this high efficiency cyclone, you saw the photo of it outside the building, is really just a separation device. It's just using, centrifugal force and separation, density separation for the fibers to go down and the hot, moist air to go up. Once we have those fibers, we're ready to package them up. And then it's really just packaging and palletizing from that point on. So that's a high level look at that. So there's my chip shelter. Those are the chips we get in. We're running spruce, fir, and pine for species right now. We had tried hemlock, learning some interesting things about how different, I'm sure people have asked me, how do different species affect your product? We've learned a ton about that. And all I can say is, yes, it does. Every little change in the process affects something else. So, and then, oh, so here's a fun one for your viewers. It's a little shame on us. So when that belt is about 12 degrees, the chips run backwards. So we just put cleats on that this week.
I think this is video from the very first chip run when we were all very excited that things were happening.
Yeah. In the winter, it was a little challenging. We had to modify some things on that belt. It's a 250-foot run to get it up to the roof at quite a pitch. So yeah, we've been working on that. So you got to get the chips up to the roof is the next step. And the next slide. This is a photo. The photo on the left and the right both show kind of that tiny tank I was telling you about. It's all insulated, and we have steam lines injecting into the bottom of it to preheat the chips. So you're going to see pressure gauges, insulated steam lines. The chips fall down through this chute into the plug screw feeder. So through that little window, you can actually see the chips there. You'll see them moving and dropping down. And then in the photo on the left, you see our digester. I said it was like a really tall, thin tank, pressure vessel. And as you exit out of the digester, it's not too impressive from the outside. When I tell people on a tour, the refiner, they're like, where's the refiner? It's like, okay, that's all you can see. But the heart of it is the plates, what I showed you before. And Jason's got a nice photo. This is what blowing fiber looks like. When we first start up the refiner, the plates are quite wide. We bring them in closer together slowly until we call it the specific energy, but the energy intensity that we want into the fibers. And then once we have that dialed in where we want it, we send it on to the flash tube dryer. It's cool, right?
This is not doing service to like
It's
how
really cool.
large and like formidable this equipment is. These pieces of equipment are like 30, 40 feet tall and are deafeningly loud and kind of terrifying to stand next to. So it's really an impressive thing to behold. Not just like a home-bred machine that's spitting out insulation. It's
I'm glad you like it.
Audio on some of this is good that it's not on.
Yeah.
Yeah, absolutely.
Oh, so this is a really interesting piece of equipment. This was new to me. I had never heard of it. Flash tube dryer. Okay, well, we're putting something wet in, we're drying it, the steam's flashing, it is a tube and it dries. So I guess I understand the naming of it. But it's really funny when you give a tour because it just looks like this long ductwork along the whole roof line. The air is moving so quickly, the fiber gets from one end to the other within 4 seconds. It goes from 50% moisture to 13 in 4 seconds. This is pretty amazing air conveying system.
And as far as process time from the chip shelter to a bag, say, of timber fill, 15 minutes?
Yeah. Yep. So what's great, I guess I'm trying to convey, my excitement for the manufacturing process, but also thinking about the customer. You don't have a long dwell time in our process. If there's an issue and I find it, I can correct it and have new fiber back on the line within 15 minutes. That's really important. Some manufacturing processes have multiple steps or batches or a long dwell time. And that either means a lot of waste. If you find something off grade or off quality, you've got all of that inventory in the line. We really don't. So it's a benefit.
You haven't mentioned yet. One thing that's really striking about the site is that all of your electricity, all of it, correct, for the manufacturing is generated on site by a hydroelectric dam that's part of the mill facility.
Yeah, Technically, we don't own it. It's not part of our facility, but we have a transmission line across the river to Eagle Creek. But yes, you are correct. That provides all of our electrical needs.
Yeah, and even at full production, I think we are 95% exclusively from that hydro, and certainly all in currently. There is natural gas for the boiler that we didn't get a shot of, I don't think, but this heat generation is that. But otherwise, there's quite a bit of electric demand in this facility. Yeah.
So here's your big cyclone. You can see the flash tube dryer going up the side of it. And then that that similar cyclone effect, if you've got the Dyson vacuum cleaner, right? Or you've worked in other industries that use cyclone for density separation. And so then it gets really, really small at the bottom. Those fibers are now at their proper moisture. And then we use a conveying auger to bring them inside. That's a nice shot, Jason.
Yeah, that was new. Edith slipped that one in there. I like that.
Nice, nice.
It's like every day I show up, there's steam coming out of the building. Oh, and this, I'm gonna, if I can get this to run. This might actually have some audio to it, but no, maybe not. Anyway, bagging line.
Does
My
Scott
favorite part right
Farrington
here.
know he's on here?
Squish.
Squish.
I'm not gonna lie, we stood here for at least a half an hour watching them wrap these beds.
It's like construction manufacturing nerd ASMR standing in front of this thing. It's totally cool.
And we got to sit there and fondle the fiber.
Oh,
was
that's
for you,
so
Travis.
great.
Fiber
That's our
fondling.
palletizer. Oh, there's Jeff. Yep.
There you go. A little plug for TikTok. Claire had put that together, and I did another round of videoing of the whole process, but that one's much more exciting. Unfortunately, we didn't get the groovy music as well, but
So I just want to make one comment. Scott Farrington, he's such a great operator on the HydroPack. That machine was made in Muscatine, Iowa. Got to go there and meet the engineers, two engineers that have worked together for 30 years. And what was really cool about them is I would really call them kind of inventors. And they just had they had such creativity and imagination on how, machines could be built simply and, reducing parts and pieces and keeping it simple. They had concepts in their machine that actually came from like sort of aerospace type of concepts, moving air around instead of touching the plastic, using air to move the plastic. You're going to see it right here, these blow bars. So instead of, you would think those little fingers, move the plastic, they do it a little bit, but really those blow bars move it for you to get it where you need to make the seal. So pretty interesting machine.
so all in 15 minutes, and then it's in a bag. This is the process flow and for timber fill. But we have a little bit more when we start talking about bat, and that is initially the same fiber stream up into the point before this bagger, correct? And then it's split at that point.
And what's also really cool too for myself with my background, as many of you know, we actually have 3 different product lines, which is really cool. So we have a timber fill line, timber bat line, and a timber board line. So because of that, we're not slowing down production of bat just because we're making more board or vice versa. So, the capacity is definitely up there.
Yeah. We have 2 refiners that one is coming online soon, and that refiner is set up exclusively for the board product. It's a more refined fiber. The timber fill and the timber bat use the same fiber size or stream, if you will. They both have the borates that are the fire retardant and mold and mildew inhibitor that are baked into the product. Essentially, they're applied wet. We can use a much lower dosing because of that. And with that, we get exceptional fire resistance and wonderful retention of that material. And for those that are familiar with blowing cellulose, it can be dusty. And some of that is the refining of paper, especially as we have recycled paper. There are less and less of us reading newspapers, but it's still out there, and the paper sources are changing. The fiber, the particulate, the smallest particulate is getting dustier. And the borates that are added in a cellulose, traditional newspaper cellulose, are added in a dry process exclusively, except for a few manufacturers. And with that, you get a lot of fine borate powder that blows back at you as an installer. It's a nuisance for the most part. It's something that gets in the way of seeing where you're going in an attic space. And the experience so far with the fiber that we've dialed in is that it performs very well. There is some of the small, I've been told it's particulate, it's not dust. Very small bits of wood fiber, if you will. But because of that, it really settles very quickly. It has a very fast flocculation.
Nice brewing term.
There you go.
That was easily my favorite part of the install that we did, just whatever that was, Dan, what, 2 weeks ago? To be able to actually be in the space and have everything settle out within a matter of seconds, to where you can actually see the work that you've done, see if there's an area you need to fill a little bit more to hit level, without that sustained dust in the air that you got from cellulose, having it all drop out so quickly. It was, 3 to 6 seconds. You could, I know that you guys wouldn't recommend it, but you could immediately like take your mask off and have a conversation with the rest of the people in the attic. It was kind of unique and impressive in that way. Even, many years working in remodeling, going into fish wires for lighting through a fiberglass attic where you're dragging wires through, and it's been blown, 15 years ago, and you can't take your mask off because it just sort of hangs in the air. That was, I think, the most impressive thing about that. So that process, whatever you're doing, it's working really well. Keep up the good work.
There you go. Jess, we've got a couple more slides on the bat line. I don't have all of them. I don't have the BICO component to this, but this and another slide of the ovens, and I'm not even sure what's next, but there's only a few more left if you want to talk a little bit about the bat line.
Hey, Jason, I have some of your BICO for you.
Oh, there you go.
Do you remember what it is?
Is that in
polyester?
Yeah.
Polyester. So it's just like shredded cotton or something like that as a texture, like shredded cotton ball is a good texture analogy for it. So yeah. Here's your visual of what it is.
Oh, that's
I was
so
wondering
great.
what happened to the feedstock from my suits. The polyester suit. Come on, guys.
So you guys like to geek out on building science. That fiber that he's holding in his cup, it's amazing what engineers can do to design these synthetic fibers. It's 50% polyester, 50% polyethylene. They design it with a core and a sheath. They can design it in different ratios and different shapes and different lengths. It's truly amazing, like the flavors of this bi-component fiber you can purchase. I'm really glad you had some. We add this bi-component fiber to our wood fiber, because if you think about what I'm trying to do with the bat product, it needs something to hold and bind it together to allow it to have some flexibility and strength. So the video that you're seeing, you're not seeing the BICO mixing step that's already occurred. So the fiber you see in what we call the ultraformer is wood fiber with, I'm going to say 5% or less of this bi-component fiber. We're forming it in the ultraformer, so you want it nice and lofty and fluffy and really well mixed. And then you can see that tapered section. So we're going to use this concept later on, but we're trying to kind of set a dimension on this mat. So the belt's moving. We've run speeds like, it's not very fast, guys. It's like 10 or 12 feet a minute. The machine's running. You can definitely beat it to the other end of the machine, but As you form those fibers, you then send them into this oven, and you can see a really nice photo of the oven here. You can see blowers, all those blue motors are blowers. In between each of those, you can see the yellow natural gas line going to a natural gas burner. So we have 12 sections, so we can individually control the temperature in those sections. We also have jacks on 2 metal wire belts. We can individually control the height of those belts. So I can gently squeeze that batt material as it goes through the oven as I'm drying it, set it to its final dimension for process consistency, so that when you guys are putting it in, you know, a 6-inch stud, you don't want variability in that thickness, right? So this piece of equipment's really going to dial in that consistency on that dimension. Oh, nice photos, Jason. This is looking down at the exit of the oven. Oh, he's got a video.
Aside from the
Was this the
bico
video
fiber,
that was this the video that you took with Steve Basic when he was up on that?
You know, I don't think it is. This was probably from Claire, to be honest. This one came from
Okay.
Edith. But
So
yes,
you guys are really getting to see the inner workings of the factory here. It looks pretty cool from this vantage point. So, oh, you're getting to see, so this is pretty neat. The saw you see moving, the flying crosscutter vector saw, is what makes the cut to length. So if we're trying to make 47-inch long bats, those 2 saws alternate to make those cuts. And then our rip saws cut them to width. Right now I'm working on a recipe for 15-inch. So this is our saw deck, our saw line. So cut to width, cut to length, and then those bats are ready to move on for bundling and packaging.
we don't have a lot on the board line, but we can maybe talk a little bit to that process. That's something that we'll probably add in the future. It's being put together currently. It's actually the first piece of equipment we had, wasn't it? And,
Yeah.
It's the only secondhand piece of equipment, but it was lightly used and low miles, according to the little old man that sold it to us. So anything to talk about on the board line or process and how that might differ from the bat?
Yeah, the funny thing I thought about the board line. So for you guys, you got to see what a mill looks like, industrial equipment. The paper machine that was in this mill was torn apart piece by piece and shipped to China. The board line that we bought from Germany was torn apart piece by piece and shipped to us. Well, they just shut this machine down. There's still board in it. Like they just shut it down. There's still some of their insulation in the machine out on the floor today as it got shipped to me. I thought that was pretty funny. But anyhow, the board product, what makes it a little different, we are currently not planning on adding the disodium octaborate tetrahydrate, our fire retardant. We're going to leave that out of the mix for now. We are going to add some other process chemistries. We're going to add a wax, and what that's going to do is give you that water repellency that you need being on the exterior of the building. And we're going to add a PMDI glue, essentially. So on the bat product, we use that synthetic fiber, so it melts and binds the fibers together. On the board line, we're actually going to use like literally a glue that cures. So on the board line, you see there's a little graphic here kind of showing where the fiber is being pressed, and you see those wavy lines are signifying steam. So this glue cures with water. So we're going to inject steam into the press section. That hot steam and condensate is going to cure that glue, and then that board is going to be set and ready to cut and process.
Great. And we just talk a little bit. I mean, I don't know, carbon footprint. Obviously, this is not what drives us, but it is at the same time. I think that the very conventional approach and traditional fit and finish of a product is very important to us, and certainly widespread understanding of what it is very important. But behind all of that is very much a mission-driven note that carbon really matters, locking up some of the carbon that you get in products themselves, and holding that, I think, is really critical. We don't have the numbers currently because we need a year's worth of data. That's something that we'll be collecting. This is based on some comparisons of European life cycle analysis board in particular, but you could see the balance between other conventional products and the carbon footprint that occurs. Dan or Jess, you have anything else to add? That's the end of slides that we've got, except for the disclaimer, which I won't subject you to at the end.
One of the things, being an outsider to Maine, one of the things that I think is really cool coming from Pennsylvania is when I get into the town of Madison, Maine, and the people in the town are just so happy, and they're very proud of their town, and the people that are working in the mill, Jessica and the entire production team are really producing a great product. A lot of them, worked in the paper mill when it was in business in 2016, and going up there and talking to the people, I find is very powerful for myself. And I think everybody out there listening right now also can really feel good about buying this product, using this product, and just knowing that there's a town behind this product that is, it's reviving the entire town. Yeah. So very humbling.
It was pretty incredible to see, like, there's kind of shuttered mill towns all over Maine since the paper industry has been exported, and to be able to drive into Madison, you see this town, and it is literally, you can tell it was like previously kind of destitute, and now is like bustling with activity and people and energy, and local delis opened up and local shops and businesses opened up to support this facility. So other than being a really incredible product, it has a pretty incredible, story around it to go with it.
Smells much better too.
It does.
It sure does.
Not anybody who's grown up or been to Paper Mill Town.
I was always told that was the smell of money, though.
Your money smells better.
Yeah.
So Travis, that was a question I had for you is, when we did your attic, the smell, I think you were the one that commented on what the product smelled like and how the installers were experiencing everything. Like, what were your thoughts on your install process?
Well, it couldn't really have been a more ideal, like, I guess maybe if it smelled like fresh baked cookies or, like a latte, maybe I would have enjoyed it a little bit more. But in terms of the comparative analysis between other products, there's not really like a borate smell. It smells like wood, and I'm a carpenter, so I like that. I like to sprinkle a little, put a little bit on each side of the neck. It draws in the fair sex. It's an appealing product. I don't have anything negative to say about it. You don't have any of the unnatural smells. I can't remember what phrase I might have said when we were there that you're probably hoping I will say. I can't remember, but I do remember very specifically going, well, this is pleasant. There's no downside. Did I describe it as something else? I know we've talked about it at length, and it was a busy day. I apologize. I can't remember the specifics.
I think you use the term, it's like frolicking in the woods in Maine.
How could you not remember that?
Because he has yet to frolic in the woods in Maine.
He's a frequent frolicker, so there's many frolics in Travis's repertoire here.
I've been known to frolic in a number of places, but you're right, Emily. I did have to reschedule my Acadia trip, so I'd be a bit of a poser if I claimed that firsthand knowledge. But I know some important people with some firsthand experience. We could probably refer and we can get confirmation on that. It's a scientific method. Come on, it's BS and beer.
Oh, did you see the comment? Oh, to Timber. Oh, that's great.
Oh, did you? Oh man. Well, we've got a line of questions, and we should try and get some of these in here while we have the time still. So Armando Cobo wants to know, in his opinion, TimberHP products are the future, but they but they really need northwest, southwest, and southeast plants to make it more affordable in those areas, just in case we also happen to build homes outside of New England. So can you guys speak to any thoughts on growth or spreading mill locations, anything like that?
We are this operation, which has been an amazing come together of so many resources and investment and amazing talent, and a lot of didn't know any better that kept them at it. It's beautiful stuff. Well, we are currently in a Series B stage of funding to raise up plant location number 2 in the Pacific Northwest. That will be years, I would say. But sure, we've got designs and hopes that we could expand anywhere that you would expect would be a fairly good fit. Pacific Northwest, anywhere across the top in climate zones 6 to 7 up there, but there's huge pine plantations down south, and many other places as well.
That leads,
sorry.
I was gonna say that leads to a couple more questions, which is where can people get it right now? Like how far are you distributing? Since there aren't plant in Texas for Armando.
Right.
So currently, we're distributing through many different insulation distributors. Timber Fill is something that we're shipping pretty much right now nationwide. Typically west of the Mississippi or east of the Mississippi, does have supply. Our northeast down to North Carolina, South Carolina, and out as far west right now as Indiana do stock it in one of our distributors, and any lumberyard you could purchase our products from. In that region, I know I've been working with Armando personally on his project, and I would say that like the price point that he's referring to, I think is part of just uncertainty because it's a new product. I mean, we offer the support of getting out to the projects and actually helping with the install team, getting them going. We did that in Kansas City with a couple projects. And I know Travis, for you especially, the Midwest, you always say is the last to get anything new. And I think you guys receive this pretty quickly.
Yeah, the mighty Midwest is we're at the bleeding edge. We're front runners. Look out, world.
Edge. There you go. Yeah.
But in terms of supply, honestly, I would say just reach out to myself and I could help with the supply. Dan.Edelman at TimberHP.com. You could follow me on Instagram. You could DM me. You could LinkedIn message. You could TikTok message anyway. So.
In that same vein, Dan, can you talk a little bit to what people can expect for comparative pricing? Is this more expensive, less expensive, on par with heritage products?
So I find it depends on the location. The shipping is definitely a big part of the price right now with shipping it from Maine. But in terms of pricing, like I've heard, we're less than blow-in fiberglass. We're a little bit more, like $1,000 more than cellulose. That was on a 6,000 square foot project, so there was quite a lot of product there. But again, I think that once the installation contractors get more comfortable with the product and get, more knowledgeable on how to blow the product, and I think Jason could talk to this a little more on the blowing portion and the speed of it. You could actually become a faster contractor when you're installing this product because you could go with bigger tubes, bigger needles, and everything else.
Yeah. We tend to be very competitive price point wise for cellulose in the Northeast, pushing into the Mid-Atlantic. Like Dan said, it's all about the shipping. It doesn't travel as well. Certainly the bat will be the same kind of scenario. It's a very light product. It doesn't compress with our packaging methodology. It doesn't have the same kind of like exciting unfolding of fiberglass. It just doesn't do that. I almost posted a video for you, Dan, just because I opened up a couple of bales that Jessica had been producing, right? And it was not exciting, but I have to say that's not the win. I get it. You know, I think that bat you'll see through various vendors, certainly closer to home. Board will travel a little bit further. And if you are looking at projects that are specific to European material already in place, that we are absolutely more competitive simply because we don't have that hop across the pond, first of all. We also have much lower energy costs. We have much lower raw material costs. We don't utilize the resources that are available to us, the byproducts of the wood industries currently, as well as we could. It certainly does happen out there. There are certainly large number of manufacturers that have been doing this for quite some time and get into cogeneration and other ancillary products with their raw material waste. But
I would also like to add that this is a premium product. You know, it is still a post-manufactured product versus post-consumer product. So I think that there's ways to sell it to your customers, just like you sell, you know, other premium installations out there. You know, we're not going to be the cheapest product out there, and that's really not what we're looking at either. You know, we're looking at being the best product out there.
This is a question for me, and it's kind of a softball for you guys. Can you guys talk a little bit about what kind of resources you'll be putting out for details and install assemblies and product use, and who you guys have developed those with?
There it is.
Yeah, that's something that seems to be an eternal and probably will be a forever project, to be honest. But we do have resources on the website for install instructions, video. Dan is often on site and documenting some of that stuff out there in the field, getting feedback. We've got some great opportunities in some very interesting places on television and whatnot. But Builder's Guide developed with the assistance of Joe Stebrick, and additional resources just on the technical side. We have evaluation service reports for every product line. We've done extensive fire testing as far as we can to this point, as well as acoustic testing and 3-part specifications. All of that can be found in the resources section of our website, or reach out to Dan or myself and we can provide that information.
While you're talking technical stuff too, and I think it might have come up in the chat box and been answered, but just so it's on the recording for people who don't get the chat box because they don't show up live, can you talk about what the R value is for each of the 3 products?
Yeah, sure. So variation depending on the install depth in a blown product. Our coverage chart represents a R value per inch. You can find that information online. Dense packed in the wall, we need a 3-pound minimum density to be self-supporting, and we get a 3.8 per inch. Our bat product in a 3.5 configuration 2x4 wall is 14 and 22 in a 2x6 configuration. We have not yet dialed in our 2x8 bat yet. That's coming, but he's got the coverage chart right there.
Yeah, I was just gonna go grab a bag of loose fill, Jason, and read it off for you, but
there you go.
good job.
So on par with or higher than other fibrous insulation materials that are currently out there.
Correct. You're going to see some variation with coverage charts and attics, with the way coverage charts were once developed and the way that we are now required to do them now. There's a progressive density, and that plays into our value. Expect to see in the board product the 1 to 9.25 inch mats, anywhere from as low as a 3.4 to potentially as high as a 3.7. That has to do again with density. So we will eventually have various densities depending on application. If it's akin to a roof cover board, if you will, more of a wet process fiber board, we can get better R values out of that, and thicker mats as well. That's also needing to be a higher density. But if you're layering, you're building up a big roof and you want a little bit of compressive strength plus some higher R values in the future, I expect that we'll have some lower density, less than 8 pounds or 8-pound density boards that will have that higher end R value. Because of that, higher compressive strength, denser mats obviously are going to have a lower R value in that case because we're just compressing them so much. But in that range, hovering around 3.5.
Along with that, there was a question about whether or not the board could be used on the roof. It was a compression question. Is timber board able to be used as roof underlayment?
Not as underlayment. We are not in our board product structural in any particular way. Although I had somebody from Canada, an architect and an engineer, argue that he could build a house out of a 9.25-inch bat just fine, and it would be just, or board just fine. And I agree. I'm not sure that's conventional building. Kind of reminds me of maybe a gingerbread house or something where you carve out the holes and all that. But yeah, it's not meant to be structural.
Gingerbread houses for Christmas. Send them out for little blocks. That'd be awesome.
Yeah, absolutely.
Oh,
We're
I
kind
think
of
that
at the
is-
point we only have time for maybe one more question. Am I right? You want to do this plan thicknesses for the board product?
yeah, sure.
What do you got? What's coming?
Yeah, so we've got initial public offering, I think, that is available online, or we could share that information. But Jess, what would you say is our minimum thickness that we'll be producing in a board product in the
I don't know. Marketing keeps telling me all this new stuff they want to sell.
Absolutely.
Yeah. So as the manufacturing person, Jason's like, well, can you make this? Do you think you can make that? So on our rigid board, on our latest IPO, I'm making a 1 inch, a 1.5, a 2 inch, a 2.5, a 3.5, a 4, a 5.5, a 7.25, and a 9.25.
There you go. And that's the outer limits. The 9.25 is as thick as our continuous press can produce a board. And the densities also are depending on that, just because when you have that squish on a thin board, you can really get that compression. So that's a more resistant to dings, dents, just better compression. I would expect to see something at 15 PSI be in that denser board. But once we get into the thicker mats, as I understand it, correct me if I'm wrong, Jess, but that core of it doesn't get as much of the squish as the exterior. So you almost get almost like a laminated board, but it's not. So expect that to be closer to the 8-pound range per cubic foot versus closer to the 10-pound for a harder board that might be something that you'd expect to see on a roof application.
Some may even say a dual density.
Dual density, yes. That would be marketing.
All right, I have to throw my one head explosion moment in here, and hopefully I'm not letting any cats out of the bags with having a copy of this yet. But in your builder's guide here, there's a detail, and I exchanged emails with Stebrick over this, where he's saying that we can use your timber board against below grade foundation walls, which that has been the last bastion for us of any plastic foam products in our building assemblies. And we now have details, and I tried to rattle Joe as much as I could through email to find a hole with this. But we can now get rid of foams below grade against exterior foundation walls and use your timber board product. So for me, that is, aside from everything else, a huge win.
Yeah, really exciting stuff. And obviously really depends on details, really depends on installation, application. But the fact that Joe, being fairly conservative when it comes to physics and all the other things that we need to pay attention to, that one is pretty exciting stuff for sure.
Well, I know there are 125 people in the audience who can't wait to get their hands on that book that Ben has, and he's been showing to everybody. So make sure you let them know when it's out, because that's going to be awesome. And I'll tell you again, QR codes on your packaging. Tell everybody how to install it.
Absolutely.
They're going to be on the Timberbat product.
You're
So
listening.
the QR code, we listen to you, Emily. We always listen to you, Emily.
No.
and they're coming.
That's
Is
awesome.
it just a hot link to a YouTube channel where Dan is blowing it in or tucking bats or stacking boards? Is that what we're dealing with, Dan? Because
That's it, 100%.
I have some soundtrack suggestions. I like beats from, you know, MF Doom and some of the others. I think that would be a really nice backing play if you're
Wow.
going to go ahead and add production value to your install.
Nice.
Dan rolling across the factory floor into a sultry.
Yeah, I got some
theme.
no FX, you know, some REM.
Oh gosh.
And we've done it. We've come off the rails. It's
Yeah.
the Beer Show.
The beer show. What a perfect way to end. I want to say
Perfect.
thank you to all three of you for coming, talking about this. I know there have been a lot of us who've been jumping up and down. Can't wait for you guys to roll this out. So exciting to see a product that's been going on in Europe for a while finally being made in the United States. So very cool. Learned a lot. Learned more tonight than I learned on the factory tour. So awesome. Thank you very much for coming on.
Thank you.
Thank
Thanks,
you.
guys.
Great to see you all. Thanks so much. Appreciate the great work you're doing. We'll see you next
Travis,
time.
what are you drinking, by the way? Now that you're in the office.
Yeah, once I got out of the truck, I went straight for the Crane, which is local out of Raytown. It's Kansas City. But the Crane Brewing Tea Vice is a favorite.
Oh, very nice. I think I've had that.
You
With
have
you.
with me. Sour
Yeah.
season year round, bro.
Yeah.
Come at me, Emily.
No.
I'm with you, Travis. All right. Good night, all.
Good night,
Thanks so
everyone.
much. We'll see you
Good
next
night.
time.
Thank you.
Take care. Thank you.